Don't worry, not on the exam, but I'll do it anyways.
On the last one.
Maybe the last one is okay. I'll do that too. So if you have your book, you could look at page 54 if you have your book. It's at home, in the bin. Page 54. So anyways, the question here, I'll write it down for you. So it said Anne invests at 12%, 12% APR converted monthly. Have you done APR with Mark O'Donnell?
No.
No, you don't. Have you heard of APR? Are you sure?
Yes.
In your life? No. No. APR means annual percentage rate. It's how much interest you pay every year. So 12% APR means 12% per year. But the interest is paid monthly. So with APR, if it's 12% a year but it's paid monthly, then that means it's 1% per month. So the other thing about APR is you need to know how often it's paid, and it's this number divided by how often it's paid. So monthly means it's 12 times a year, so it's 12% divided by 12, which is 1%. Yes? So what happens in the story is Anne invests some money, we'll call it A, and she wants to know how long until she doubles her money. So if she starts with A at the beginning, after 1 month, how much does she have? How do you increase A by 1%? Any ideas? You multiply it by...
1.1.
So close. So close.
0.1.
1.01. After 1 month, she has this much money. Then after 2 months, 1.01 again. So there's a square here. You multiply it again. And then after 3 months, cube. So we want to know after how many months until she doubles her money. This is, I'll write it down for you. It's page 54, question 4. Okay, so what can I cancel? I can cancel the A's. And how can I get the T? What can I do? Yeah, log. So I get T is log 2 over log 1.01. Yeah, what's that? Rounds up or rounds down? 69 point? Yes, so 70 then. She wants to know how, well, we must round it up because she wants to double her money. So I feel like even if it was 69.1, we should still make it 70. Because if we round it down to 69, she hasn't quite doubled her money. It needs to be at least 70 months until she has double the money than what she had at the start. Yeah. Okay.
But I think they want to use exponential equation.
Well, this is one way to do it. I wrote the question, so I would be happy if you did it this way, you know. I don't, for this question, there's no need to convert this into an exponential like this. Not for this one. You can leave it as 1.01. Yeah. It's okay now? Yeah. Well, we do number 8 on that page. So in number 8 on the same page, you had y equals AEBX. And by using log, I wanted you to rewrite this in a linear way. So, if you put log on both sides, you get log y equals log a e b x. So you get log y equals log a plus log e b x. But log and e cancel. So you get log y equals log a plus bx. So you get log y equals bx plus log a. Now if you look at it like this, if you call log y some new letter like y dash or v or u or whatever, and if you keep x as x, then you actually have something which now looks linear in its graph. This is like the slope and this is like the intercept. So like if I said plot log y against x, your graph will be a straight line now. If you use, instead of using y as your point, if you use log y, you'll get a straight line. Have I got my program open? No, I don't. I'll give you just to help visualize this, I'll give you an example of what I mean. Then I think we'll leave it at that. Okay. So let's pick some simple function like y equals 2e power 3x, something like this, okay? So here's my x and here's my y. So we'll go 0, 1, 2, 3, 4, 5, 6. And then my y would be equals, what did I say, 2 times e power 3x. So here are my y's. Now you know what this graph will look like. What will it look like? It'll be increasing graph, won't it?
Yeah.
Yeah. So what my short little proof shows, that if instead of plotting x and y, if I plot x and log y, I think I should. So if I plot this and this, I should get a nice straight line now. Blah, blah. X and log of the y values. See, now you get a straight line instead of a graph. And in fact, the slope of this line would be b, and the intercept will be log a, where it crosses the axis. It's the last question on that page 54, and it's a kind of a tiny bit more difficult than what you might need for the exam. But this is a useful trick that you will probably see again if you can go and do some maths at university, where if you have an exponential graph and you want to draw it as a straight line, if you use log of all the y values, the graph becomes a straight line then. So this is something that you have a chance of seeing next year. But for us, it's probably, as an idea, maybe a little bit too difficult for the exam. Okay. Any questions about the exam?